So weekly pop quiz 11 and the MCQs pop quiz 11. If you have a doubt or a question, you can ask. Any doubt in question 1? Question number 1, any doubt? Question 2, any doubt in question 2? Question number 3, any doubt? Question 3. Question 4, any doubt? Question 4. This was a weekly pop quiz 11, the MCQs pop quiz 11. Question 5, any doubt? 5, 6. No doubt in 5, 6. Question 7, any doubt? Question 7, okay. Question 5 as well. Question 5, which statement of about the sound wave is in air is at a constant temperature is correct? So if the temperature is not changing, the speed of a sound will not change. The speed will be constant, and we have the formula V equals F lambda. If speed is constant, what is the relation between the frequency and the wavelength? So frequency and the wavelength are inversely proportional if the speed is constant. So which statement about the sound wave is in air? Amplitude is inversely proportional to velocity. No, amplitude is not related to velocity. Amplitude and intensity are related to each other. It is proportional. Intensity is proportional to amplitude square. The frequency is inversely proportional to wavelength. That's right. Why? Because if the speed is constant at a constant temperature, the speed of a sound will not change. So if the speed does not change, if we increase the frequency, the wavelength will decrease. But the product of the speed and the wavelength will remain unchanged. Then in question 7, a basic principle of note production in a horn is set up a stationary wave in an air column. So when stationary wave is produced in an air column, there are two possibilities. It might be a closed pipe or it might be an open pipe. So for a musical instrument, because this is a mouthpiece where we blow the air, so this is considered as a closed pipe, like one end is closed. So in a closed pipe, what are the frequencies produced? Like if the first frequency for the fundamental frequency is F, then it will be 3F, then it will be 5F, 7F, 9F, 11F, and so on. So it will be a multiple of odd number, for a first harmonic, second harmonic, and so on. So if the fundamental frequency, as I mentioned, for the lowest note produced by a horn, a note is formed at the mouthpiece, and anti-note is formed at the bell. So there is a note here and there's an anti-note. This also confirms that this is a closed pipe, because if it was an open pipe, then in an open pipe, both ends will have anti-notes. So we'll always have antinodes if it's an open pipe. That is the minimum pattern for the open pipe. But in a closed pipe, one side will have node, another side will have antinode. So this is a closed pipe. And these are the frequencies for the multiple harmonics according to the number of vibrations. So minimum is 75. So then what is another frequency we might have? It will be 3 times 75. That is another frequency. Then what will another frequency? It will be 5 times 75. So means 3 times 75, that will be 225. So 225, it means the first higher note, the second higher note, it will be 5 into 75. So 5 multiplied by 75, that is 375. So this will be 3 and so on. So these are the nodes which are produced. That's why D will be the right answer. Question number 8, any doubt? Question 8. Question 9. Question 9, even though maybe you don't have a doubt, but I will explain the idea because repeated questions are there. Question 9, okay, sure. Look, in question 9, this is a very common type of a question you will find in exam related to diffraction grating, the MCQ. And some structure questions are also related to this. A diffraction grating with a 500 lines per millimeter is used to observe diffraction of a monochromatic light with a wavelength of 600 nanometer. The light is passed through a narrow slit and the grating is placed so that its lines are parallel to the slit. Light passes through the slit and then the grating. An observer views the slit through the grating at different angles, moving his head from X parallel to the grating through Y and then opposites the slit to the Z parallel to the grating. So he moved from here till this point. How many images of the slit does he see? So first, whenever you want to find the order of image, what is the formula? The formula is d sine theta is equals to n lambda. And what is the maximum or maximum angle which we can see? Because they mentioned he started from parallel to the slits and then he moved to Y and then from Y he moved to Z. But we'll take only the first half. So when we take the first half, what could be the maximum angle we have? The maximum angle we can have is 90 degrees. So the theta here will be 90. What about D? D is the spacing between the slit spacing. So how we can work out the slit spacing? That is the total length of the grating element divided by the number of the lines. 500 lines per millimeter, like 1 millimeter is having 500 lines. If we convert 1 millimeter into meter, so it will be 0.001. That is the total length of the grating in terms of meter, because we divide by 1 millimeter is equivalent to 0.001 meters. So 0.001 meters divided by total number of the lines. How many lines are there? There are 500 lines. So we divide by 500. What's the answer for this? If we have 0.001 divided by 500, what's the answer for this? 2 exponent minus 6. Okay. So we got, this is 2 into 10 to the power minus 6 meter. That is D. We got the D. So we have the D, we have the theta, and the wavelength is 600 nanometer. So it will be 600 into 10 to the power minus 9 meter. We'll substitute the values. So the value of a D is 2 into 10 to the power minus 6, negative 6. Sine 90 is actually 1, so we don't have to calculate. N is the order of image, like how many fringes we'll get, that is N. That is what we are finding first. And lambda is 600 nanometers, so 600 into 10 to the power minus 9. When we simplify, So it will be 2 into 10 to the power minus 6 divided by 600 into 10 to the power minus 9. What's the answer for this? The value of n? So value of n is 3.33, but n should be a whole number because it should always be the whole number. That is the order of image. So means how many we will get? The one will be n is equals to 1, n is equals to 2, n is equals to 3. So three images minimum because it should be a whole number and we take a minimum rounded off but to a lower value. So n is equals to 3. So maximum, why n should be a whole number? Because n is a order of image. Order of image, you cannot have like 1.5 order. You will have n is equals to 0 order, then you will have n is equals to first order, n is equals to second order, n is equals to third order, and so on. So order of image cannot be a decimal or a fraction. It will always be a whole number. So n is representing the order of image. So why not 4? Because as you can see, when we calculated the value of n, we got 3.33, the order of the image. So when the angle is 90, when the angle is 90 degree, within this angle, how many images we will get? The whole numbers, it will be n is equals to 1, n is equals to 2, and n is equals to 3. N is equals to 4 will be here. So which is not possible because the maximum within the 90-degree angles, we are getting 3.33 orders. So minimum will be, the whole number will be 3. So same way, we will get 3 order of the image on the up. Same way, what we will get? We'll get the 3 order of image down. 1, 2, 3. Because above and below, this will also be n is equals to 1, n is equals to 2, and n is equals to 3. And the central maxima is there, which is n is equals to 0. So how many, the question is how many images of a slit does he see? So how many images he will see? As you can see, 3 below, 3 above, and 1 at the center. So how many are there? 3, 3, and 1. So order of the image, the total images, what he will see? He will see 7 images. Is it clear? Question 10, any doubt? You have to learn the range of the wavelengths for different electromagnetic waves. Using the range, you have to work out which could be the ultraviolet and which one is the infrared. Question 11. The traveling waves of a wavelength 20 centimeter are created in an air column in a closed pipe and an open pipe. The lengths of the pipes are shown. In which pipe or the pipes are stationary waves formed? How we can identify the formation of the stationary wave? When it is a closed pipe, the minimum pattern we have is one node and another antinode. That is the minimum pattern we have. So the distance between the node and the antinode should be, it is quarter of the wavelength or lambda by 4. So we can say, first I'm doing for P, and we are using a wavelength of 20 centimeter. We want to identify whether a wavelength of a 20 centimeter can produce a pattern or no. So if it was a fundamental frequency, then the length should be equals to the quarter of the wavelength. Like length should be lambda by 4. Or we can also say lambda is equals to 4L. If lambda is equals to 4L, So the minimum pattern which can be minimum wavelength which we can use here, like the wavelength which we can use, it will be 4 multiplied by 35. So 4 multiplied by 35, that is 140 centimeter. So the length, the first thing for a minimum pattern, the wavelength should be 140 centimeter. So that, but we have 20 centimeters. So means it is not producing a fundamental, it will not form a standing or a stationary wave. Now, can it produce a second pattern? What is the second pattern? That this is a second pattern. And there's a formula. Directly, I will write the formula. But first, for explanation, I'm explaining the idea how it can be done. So this is the total length and how much it is in terms of the wavelength. Distance between the two successive nodes, that is equals to lambda by 2. And the distance between the node and the antinode, that is lambda by 4. So what is this total length? When we add them, so 4 will be LCM, so it will be 2 lambda plus lambda. So it means this pattern will be 3 lambda by 4. So for this pattern to produce, the second harmonic which we say, the first was a fundamental frequency, and now for this pattern, so lambda, the total length should be equals to 3 lambda by 4. If I need lambda, the wavelength which is producing this pattern, so it will be 4L by 3. So 4L by 3, 4 multiplied by L, L is what, 35 and divided by 3. So 4 into 35 divided by 3, what's the answer? So 4 times 35, it was 140 and 140 is divided by 3. So 46.6. So for this 46.7, you can say rounded off. So 46.7 means to produce this pattern, the wavelength should be 46.6. So it's not there. We have 20 because we want to work out whether 20 can produce a pattern. Then if we have this is another possibility. We'll have node, 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 and antinode. Distance between the three successive nodes, that is lambda, and the distance between the node and antinode is the quarter of the wavelength, lambda by 4. So when we add, this will be 4. The LCM will be there. So this will be equals to 4 lambda plus lambda. So it is equals to 5 lambda by 4. So it means the length should be equals to 5 lambda by 4. Or the wavelength which can produce this pattern, it will be 4L by 5. So it will be 4 multiplied by length, which is 35 divided by 5. So what is the answer? 4 into 35, that is 28. So we don't have the wavelength 28. 28 will produce this pattern. What is another pattern which can be produced? So this is another pattern. We will have, this will be lambda because 3 successive nodes. This will be lambda by 2 and this will be lambda by 4. So we'll take an LCM. So it will be 4 lambda plus 2 lambda plus lambda. So it will be equals to 7 lambda by 4. So L is equals to 7 lambda by 4, or if we need lambda, it will be 4L divided by 7. So 4L divided by 7, 4 into 35 divided by 7, what's the answer? So we got answer as 20 centimeter. So means 20 will get. So it means the wavelength of a 20 will produce this pattern. So yes, there will be a standing wave in P. So instead of an exam, because you don't have to draw all of this again and again. So what is the rule? What is the relation between the length for a closed pipe and the wavelength? If it is a first harmonic, it will be lambda by 4. Or you can also, if it is a second harmonic, it will be 3 lambda by 4. If it is third harmonic, it will be 5 lambda by 4. If it is fourth harmonic, it will be 7 lambda by 4. If it is fifth harmonic, it will be 9 lambda by 4. So like multiply by the odd number and divided by wavelength, multiply by odd number, divide by 4. So you will check the pattern by using these formulas. So what it shows that the P will produce a standing wave with the 20 centimeter. Now we have to check for Q. So the minimum pattern, it's an open pipe. In an open pipe, the minimum pattern is antinode, node, and antinode. So the distance between the two successive antinodes, that is lambda by 2. So we can say L will be equals to lambda by 2, or lambda is equals to 2L. So lambda is 2L. So 2 multiplied by length is 50. So what we get? We get 100 centimeter. So 100 centimeter is the wavelength of this wave. But we want to check whether a 20 is producing a pattern at wavelength of a 20. Then the second pattern which we can have, we'll have antinode, node, node, and antinode. The distance between the two successive nodes, that is lambda by 2, this will be lambda by 4, and this will also be lambda by 4. So means when we add them, quarter of the wavelength twice plus half wavelength, so L is equals to lambda. So if the length is 50, the wavelength will also be 50 for this pattern, for production of this harmonic. The wavelength should be 50. But we don't have a wavelength 50, we have 20. Now we check the third one. If two loops are there in between, so we have antinode and antinode. This will be node, node, node. So this distance is equals to lambda, because three successive nodes, this is lambda by 4 and this is also lambda by 4. So how many, in terms of when we add them, it will be lambda by 4 plus lambda by 4 plus lambda. So that is equals to 4 will be the LCM. I can directly say it will be equals to lambda plus 4 lambda, or that is equals to 6 lambda by 4. Or 1.5 wavelength we can say. So L is equals to 6 lambda by 4. If you need wavelength, so it will be 4L divided by 6. So it will be 4 times the length, which is 50, divided by 6. So it will be 200 divided by 6. That will not give us the result. Then we have a pattern. If 3 loops are there in between, this is antinode, this is antinode, this will be node, 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 node. So this is the quarter of the wavelength. This is one wavelength, and node and antinode is half wavelength. So lambda by 4 plus lambda by 2. So it will be lambda plus 4 lambda plus 2 lambda. So we will get 7 lambda by 4. So L is equals to 7 lambda by 4, or lambda is equals to 4 into L divided by 7. So it will be 4 multiplied by L, which is 200. So 28 we got. So this is not producing. And further, when we check, if 4 loops are there, this was a 3 loop, I think. Yeah. 1, 2, 3. Now 4 loops are there. The space is so short, that's why 4 loops. No, I made it 5 loops. 1, 2, 3, 4. Yeah. So it will be antinode, antinode, and nodes are there and these points. node, 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 and node. So distance, this is one wavelength. This is one wavelength. This is quarter of the wavelength. This is also quarter of the wavelength. So when we add them, 4 will be LCM. So this will be lambda. This will be 4 lambda. This will be 4 lambda. And this will be lambda. So when we add, it will be equals to 10 lambda by 4. So L is equals to 10 lambda by 4. When we simplify for a wavelength, it will be 4L divided by 10. So 4L divided by 10. So it will be 4 into 50 divided by 10. So 200 divided by 10. What we get? We get 20. So means the wavelength of a 20, because wavelength of a 20 will produce a standing wave here or a stationary wave. Is it clear, this concept about the relation between the wavelength and the loops? Any doubt in this? Okay. Next is question 12. Standing wave question. Question 12. Question 13. Question 14. Question 15. Question 16. In question 16, the diagram shows two identical speakers in phase by a common audio frequency source. When the student moves a line XY, she notices that there's a variation of a loudness of a sound. That is due to the interference, constructive and destructive interference. How may the distance between the loud region be reduced? If you want to recall the idea of a diffraction, that we have the formula that the lambda is equals to AX over D. That is the formula. What is D here? D is a distance. This D is a distance. What is A here? A is the separation. As you can see, the separation is A. And X, what is X? X is a distance between the two successive crest, or you can say the distance between the two successive parts of a constructive interference. So that is X. In the question, the region in which the herd is alternate loud and quiet indicate the diagram. How the distance be reduced? Like we want to reduce X. So if X is our subject, so lambda D over A will be equals to X, according to this formula. We want to reduce the value of X, according to the question. Decrease the distance A between the speaker. If I decrease the distance, if I reduce the distance, what will happen to the X? The X will increase. So this is not the right answer. Increase the distance D. If I increase this distance D, what will happen? Because both are in numerator, so what will happen to X? X will also increase. So this will not be a right answer. Increasing a frequency. If we increase the frequency, because the speed is constant, if we increase the frequency, then what will happen to the wavelength? The wavelength will decrease. And if the wavelength is decreased, what will happen to the value of the X? The value of the X will also decrease. So C will be the right answer. And amplitude, increasing the power. If we increase the power or amplitude, the louder will be much louder than what we heard, but the positions will not change. So these three A, B, C can affect, but the effect of A and B were opposite. That's why C is the right answer. Is it clear, this one? Question 16, yeah. Then 17, any doubt? Question 17. Question 17. Question 18, any doubt? Question 18. Question 18 is a similar one which we solve. The same way we will solve. The monochromatic light which is having a wavelength of 690 nanometer. So it will be 690 to 10 power minus 9 meter. A grating element which is 300 line per millimeter. Usually it is in millimeter, but if we need the D, that is because we are using a formula D sine theta is equals to n lambda. So D sine theta will be equals to n lambda. So how to work out the D? D is the total length of a grating element divided by number of the lines. So that will give us the spacing between the slits. So what is the total? It's per millimeter. 1 millimeter has 300 lines. So 1 millimeter means like 0.001 meter. And how many lines are there? 300. So we divide by 300. What's the answer for D? What's the answer for D? 0.001 divided by 300. 0.001 divided by 300. That will give us the value for D, which is 3.33 into 10 to the power minus 6 meter. Now, D, we have the D, which is 3.33 into 10 to the power minus 6. What about the angle? Again, the same, like this is a central maxima. What should be this angle? The maximum angle will be 90 degrees. Because the greatest number of the maxima we want to observe. So the sine, the theta will be 90 degrees. N is the order of image we don't know. And what about the wavelength? We use 690 nanometer. So 690 into 10 to the power minus 9. So we need N. So 3.33 into 10 to the power minus 6. Sine 90 is 1. And divide by 690 exponent minus 9. What is the value for N here? N is equals to 4.8. So if N is equals to 4.8, what I will take? I will take 5, I will take 4. We always take this rounded off to a lower number because till this point, yeah, we'll take 4. So N is equals to 1, N is equals to 2, N is equals to 3, N is equals to 4, and then N is equals to 4.8 is here. And N is equals to 5 will be after. So we don't take 5, we'll take 4. Don't try to round off this. So this is 1, 2, 3, 4. And same pattern we will have below, this which will be N is equals to 1, N is equals to 2, N is equals to 3, and N is equals to 4. 4.8 will be there, but we will not take that because we take the whole number. So what is the maximum order? The central maxima will be there, and 3 images below and 4 images below and 4 images up, or 4 towards right and 4 towards left. So what is the maximum order we'll see? We'll see 9 images or 9 maximas. Is it clear? The concept of a grating? Question 19. Any doubts? Question 19 or question 20? Question 19, 20, no doubt. So this was a pop quiz related to mostly the standing wave questions.